All right, welcome to day one, practice problems. We got 20 problems for you today. We're going to get started with this one. 2x times, and then in parentheses, 2x to the power of 3. So when I look at this problem, right, I can tell this is not an equation. This is definitely an expression. Obviously, there's no right side here. It's just got a question mark. So I can tell it's an expression. Now, when I talked about expressions, there was two things we're going to do. We're either going to simplify or we are going to evaluate. And since I don't know the value of x, it doesn't say, oh, x is 10 or x is -1. Then I know that I'm supposed to simplify. So I'm going to rewrite this in a way that basically makes it the same thing but look different. All right, so first thing we got to remember is that we live under the world of PEMDAS when we're simplifying expressions. So things in parentheses happen first, then we go to exponents, right? We got to remember that when we're doing this, we're living under this world of PEMDAS. All right, so I might try to do parentheses first. So if I look here, I see a parentheses, there's something inside that parentheses, 2x. Remember, that is 2 times x. But if I really think about it, I can't actually multiply those things together because I don't know what x is. If it was 2 times 3, I could do it. But 2 times x is just 2 times x. There's no more simplifying there. So my next step would be to go towards exponents. So I've talked about parentheses. Now let's look at exponents. So yes, there is an exponent, right? I've got that little 3 there above the 2x. So I need to multiply this thing inside the parentheses 3 times. So I'll show you kind of the long way. There is a little bit of a shortcut here. But first of all, we'll go like this. 2x times 2x times 2x. That's what the third power means. It means we're going to multiply it 3 times. So when I multiply 2x times 2x times 2x, I know that I multiply the numbers first. So 2 times 2 times 2, that gives me 8. Then I'm going to multiply the variables, x times x times x. And that gives me x to the third power. Okay? Now remember, there's still this 2x being multiplied by that. So I need to do that at the end as well. All right? So now I'm done with exponents. Really now I'm down to multiplication and division. So remember, I start from left to right. There is no division. There's only one multiplication. So I'm going to go ahead and do that. Again, when I multiply terms, I multiply the coefficients first. 2 times 8 is 16. Then I multiply the variables. X times x to the third. Now don't forget, this is x to the first times x to the third. 1 and 3, if you gather all those together, you get 4 total. That's going to give me x to the fourth. All right? So that is going to be my answer. Now, there is a sort of a different way to do this problem, and I'm going to talk about that really quickly. All right? There's nothing wrong with doing it that way. This way is just a little bit different. And in a different problem, this could make a difference, so it's worth showing. So if you look back to what we did over here, okay, if you look back to what we did on the left side here, you notice that I had, goodness, it disappeared on me. So 2x, and then this thing multiplied 3 times, okay? So really, we're multiplying the 2 3 times. And then we're also multiplying the x 3 times. Both of those things, the 2 and the x, get multiplied 3 times. So what you can do here is you can remember that 2 is to the first power, and x is also to the first power, and you can multiply those inside, okay? This works a little differently than when we multiply terms, how we add variables. This works a little bit differently. So this would be 2 to the third power times x to the third power. Notice when it's a power to a power, we multiply, okay? Now, 2 to the third, I can actually evaluate that. 2 times 2 times 2, that's 8. And we still have our x to the third. And you'll see pretty quickly that we're going to get the same thing we got on the left side. So that's a little bit of a shortcut. Now, when it really helps is when you're doing something like this. Okay? If you write out this thing 5 times, it's going to take you a long time to do that. So that would be a good time to use this trick. Multiply, 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 2 to the 5th, x to the 35th, y to the 20th. And then, of course, simplify that 2 to the 5th as 32. But that would save you a lot of time there. So that there's definitely some benefits to this, although in this problem, not necessarily as important to know that trick. Just make sure you follow PEMDAS's rules. All right, next question. In the expression 2x squared minus 5nx equals 18. If x is equal to -2, what is p equal to? Now this is a mistake here. This is supposed to be an n, so I'll go and change that. All right, what is n equal to? All right, so is this an equation or an expression? This is actually an equation, okay? But they're gonna treat it sort of like evaluating how they give us the value of the variable. So anytime you know the value of a variable, you always plug it in. So that's the first thing you should do. So 2 times x, and since we know x is -2, I'm gonna go ahead and plug it in. 5n times x, which is -2, equals 18, okay? So I'm sort of evaluating. Now I don't know what n is, okay? But the question asks, what is n equal to? So that sort of sounds like solving. So I need to solve for n here. And remember, that sort of means I need to get n by itself. So I need to go ahead and get rid of all these other things that I see. I need to get rid of this. I need to get rid of all this stuff. I need to get rid of this. All right. So 2 times -2 squared minus 5n times -2 equals 18. All right, here we go. So let's simplify. We should do the squaring first. So we square the -2. -2 squared means -2 times -2. All right, -2 times -2 minus 5 times n times -2 is 18. All right, -2 times -2 is +4, right? Two negatives multiply to be a positive. Got 2 times 4 minus, now actually technically here we've got two negatives that are being multiplied. The n's in the middle, but I'm allowed to move the n over to here if I want. If I move the n to the right, I have -5 times -2, which gives me a +10 n. And that's going to equal 18. Okay, so we've almost simplified it enough here. We'll go ahead and multiply 8 plus 10n equals 18. Now we've got it down to where we need to just solve for n. Okay, subtract 8 from both sides. That gives you 10n equals 10. Then we divide out the 10. We're going to have n solved for. N is equal to 1. So the value of n is 1 when x is equal to -2. Remember, if x was something different, it would give us a different value of n, but we would do it the same way. So this is an interesting problem because it's an equation, and we're still solving, but we need to do that extra step of using that value of -2 for x. We need to plug it in first. Now you could plug it in later. That's okay, but we'll go ahead and plug it in first. All right, next problem says, what is the value of x if 7x minus 15 equals 62? Okay, so the whole point of this lesson for day one was to talk about expressions versus equations. This is pretty clearly an equation. It's got a left side and it's got a right side. It's got an equal sign in the middle. So I can tell that this is definitely an equation. And the words, what is the value of x? That means to solve for x. So we are going to solve this equation for the variable x. So if I take my equation here, I'm going to go ahead and rewrite it. I need to get rid of everything on the left side of the equation. I want to get that x by itself. So to get rid of the minus 15, we're going to add 15 to both sides. Okay. The 15s cancel because they add to 0, and 7x plus 0 is just 7x. So it simplifies to be 7x over here, and on here, the right side, we get 77. All right, 7x equals 77. Last step would be divide by 7. That's going to give me x equals 11. Okay, so x is equal to 11 in that equation, and we've solved for x. So 11 is going to be our solution. All right, next one. Which of the following is equivalent to 6x squared minus 3x minus the quantity, in parentheses, 13x minus 4x squared? All right, so this one is not an equation. There's no equal sign. There's no left side and right side. This is definitely an expression. So we're either simplifying or evaluating. And I don't see anything that says x is equal to a number. So we're not actually evaluating. We are going to simplify this. So we're going to remember that we're still living under PEMDAS. We're going to follow those rules. All right, so the first thing I see here is that minus sign out front. Okay, that makes me think that I'm subtracting this whole thing. So I'm going to go ahead and distribute that minus sign into both parts. Now remember, when we distribute, we're actually multiplying. So we are going to multiply that negative inside the parentheses to both of the terms, right? We got to hit both terms with that negative sign. All right, so this all stays the same over here, 6x squared minus 3x. Now when we multiply that negative inside, all the negative does is switch the light on or off. It's like a light switch. That positive number becomes negative. If it's negative, it becomes positive. It's turning on and off a light switch. So that positive 13x becomes a negative 13x. That negative 4x squared becomes a positive 4x squared. Remember, if it's just a negative, it's just going to change the sign. All right, so we've got this thing a little closer to being done. Now all we need to do is find like terms. So I see squareds and squareds. Put them together. 6x squared plus 4x squared is 10x squared. All right, next thing I see this minus 3x and this minus 13x. We can combine those. Minus 3 minus 13 is negative 16x. And that is the simplified version of that problem. Okay? Chances are you'll see a problem like this on the test. This is pretty standard, just a simplification problem. All right, next problem. If there are n students in the school and k students don't take a math class, what fraction of the students aren't taking a math class? Okay. To solve this, we are going to need to write an expression, okay? There's nothing here that makes me believe that this is going to be an equation. It's just going to be an expression that represents the fraction of the students that aren't taking a math class. So one of the strategies we talked about is trying this with numbers. So what if instead of n students, okay, what if it said there was 5 students in a school? And 1 student wasn't taking a math class. So there would be 4 students that did take math. And how would we find the fraction of students that aren't taking a math class? Well, we would take the total number of students that are not taking a math class and divide it by the total number of students. So it'd be 1/5. Okay, let's try another set. What if there's 100 students this time? And 30 of those students did not take math. That would leave 70 that did. What fraction of the students aren't taking a math class? Okay, so we would do 30 students not taking a math class, and we would divide it by 100. Okay, now of course we'd want to simplify that fraction, but this is just a pretend example. We're just making something up right now. So now let's go to where we don't know the number of students. So let's say we don't know the number of students that are in the school. Let's use a variable. Well, since they use n in this example, we're going to use n in this example. Now, how many students do not take a math class? Well, there's k students. So we're going to say, okay, there's k students not taking a math class. Now go back to these answers. How'd you get a 1 and a 5? 1 divided by 5. Well, you did this divided by this, right? How did you get 30 over 100? Well, I did this divided by this. Well, do the same thing with these variables. This divided by this. So k divided by n. It's that simple. Now, this is a pretty easy problem, but it helps you kind of realize that this strategy is really beneficial. So if you're setting up an equation or an expression, you can use this strategy. All right, next question. Terry parks his car in a parking lot that costs $A per hour for the first 8 hours, then $B for each hour after that. The following table shows the hours he parked his car during his work week. So they have the 5 days that he parked his car and the number of hours for each day that he parked. Which expression represents the cost of parking his car for the week? All right, so a couple things here. It says write an expression. So we're going to write an expression that represents the cost. So when it says represents, that usually means we're going to have some variables here. So A is the number of, it's the cost per hour for the first 8 hours. And then B is the cost for each hour after that. So let's try this one with some examples. What if A was $10 and B was $20? All right. Looking at this, we could calculate the cost of parking in this garage. So for the first 8 hours here, right, there's 10 hours total, but the first 8 hours he was charged $10 per hour. So I would say $10 times the first 8 hours, okay, plus $20 for those 2 additional hours, okay? That would be day 1. So day 2, we would want to add that cost, right? Day 1 plus the cost of day. We're just going to add up all the cost of each day to get the total, okay? The next day would be $10 times 3, because he had 3 hours at a $10 rate. That's day 2. So day 1, day 2, we're going to add to that day 3. Day 3 was 8 full hours. So that's $10 per hour times the number of hours. That would give you the total. So there's day 3. Day 4, there's 10 hours at $10. So $10 times 10 plus how many hours would he have left over? It looks like 4. So there'd be $20 charge for those 4 hours. All right, there's day 4 plus day 5, 9 hours. So $10 for the first 8. We're going to add to that $20 for that first day. Okay, so that's just an example when A is 10 and B is 20. So we picked numbers for those variables, right? Now, what if I picked A that equaled $1 and maybe B equaled $2? Well, what would change in this expression? Because I've got an expression right here that represents the total cost. What would change? Would the hours change? No, the thing in the parentheses wouldn't change. It'd be the cost. So that number in front would change. Okay, so what that means is, what if I let A and B be variables now? So we're not going to let them be numbers. We're just going to let them be variables. Well, I would replace those from the expression with A's and B's. So every time I see a $10, remember $10 was A, so I'd put an A right here. So it would really say A times 8 plus $20 times 2. That's the cost of B. So B times 2 plus. Every time I see a 10, I'm going to put an A. So A times 3 plus A times 8 plus A times 10 plus B times 4 plus A times 8 plus B times 1. Okay? Now, this is a little weird because the number, the coefficient, is after the variable. So I would want to actually flip these around if I rewrote this, because we don't say I have truck 7. We say I have 7 trucks. So the number always comes in front of the variable. And that's okay to just flip those around. So really it's 8A plus 2B plus 3A plus 8A plus 10A plus 4B plus 8A plus 1B. Remember, 1B I can just write as B. That's the expression. Now, you won't see this as any of the answer choices because we haven't simplified it, right? We write an expression, we always want to put it in simplest terms. So what I would want to do is combine all my A's together. I have 8 plus 3 plus 8 plus 10 plus 8. If I add all those together, well, I get 19, 29, 37. So I get 37A. Okay? Now, how about all the B's? I've got 2 and 4 and 1. That makes 7. So plus 7B. That expression represents the total cost for any cost. A and B could be any cost. We're not sure. Remember, we tried it with 10 and 20, tried it with 1 and 2, and then we left it as just a variable. So for any cost of A and B, this expression, 37A plus 7B, would represent the cost of parking his car for that week. All right, moving on. Let R represent the revenue from selling cars and trucks. If trucks cost $12,000 and cars cost $9,000, write an equation that shows the profit from selling C cars and T trucks. So technically, I think this word profit maybe should be read. All right, here we go. So again, this is an equation. So we're going to have an equal sign this time. We're going to let R be the variable for revenue. And we've got 2 other variables, C for cars and T for trucks. So let's try it without variables. Let's try it with actual numbers here. Okay, the same strategy as we did before. So what if I bought 2 trucks and 3 cars? What would my revenue be? My revenue, sorry, that's an R. My revenue would equal 2 trucks. So 2 trucks, they're each $12,000. So that'd be 2 times 12,000. Then I want to add the cost of the cars. 3 cars at 9,000. So 3 times 9,000. Okay. Now, I'm not actually going to even worry about what that is. I'm just trying to see the structure here. Okay. So let's try it again with 12 trucks and 3 cars again. So my revenue would be, again, the 12 is now, or the 2 is now a 12, so I just replace that. It's getting pretty obvious what the equation is going to look like. What if I did C cars, excuse me, T trucks? That's an awful looking T. Let's try a better looking T. T trucks and C cars. So this is the whole point. What is it going to look like when they're just variables? Well, the equation is going to be the same structure, right? Trucks was 2, this 2 is right here. When trucks was 12, the 12 is right here. When trucks is T, the T is going to go right here. Now, if you remember from the last problem, we're actually going to switch that because I don't say T 12,000, I say 12,000 T, and you won't see T 12,000 on the test. Same thing here, though. When cars was 3, you saw 3 here. When cars was 3, again, a 3 was here. So the same thing is going to happen when I have it be C cars, C times 9,000. Now, go ahead and put your numbers out front, just because it's tradition, we write it with the number out front. And then you're going to have your equation that describes the revenue for buying T trucks and C cars. So just remember that strategy. Try it once, maybe twice if you're really not seeing how the structure works. See how the structure works with numbers. It should be the same structure when you go ahead and use variables instead. All right, next problem. Which of the following is a solution to the equation 3x minus 2y is less than 15? All right, so we've got some different choices there, okay? So why don't we just try plugging those in, right? If it's a solution, when I plug it in, it should work, right? So let's try the first choice. 3, -2, okay? When I plug in 3 for x and -2 for y, if it makes sense, it's going to be a solution. If it doesn't, it's not going to be a solution. All right, 3 times x, where x is 3, because we're saying x is 3, minus 2 times y. Y is -2. Is that less than 15? That's the question, okay? Go ahead and simplify here. 3 times 3 is 9. A -2 times a -2 is a +4. We get 9 plus 4 is less than 15. That simplifies to be 13 is less than 15. So I've got this equation here at the bottom. Is it true or false? If it's true, those numbers are solutions. If it's false, they're not. This happens to be true. So we know that that solution is true. Now, let's look at B, okay? B was 0, -10. Okay, just to show you what it would look like if it wasn't a solution. So when I plug that into my equation, 3 times x, right? X is 0, so I plug in 0 for x. Minus 2 times y, y was -10. Is that less than 15? That's the question. 3 times 0 is 0. -2 times -10 is +20. Do we get something true here? I get 20 is less than 15. That's not true, which tells me that that solution is not really a solution. So again, this strategy of just plugging in numbers and seeing which ones are solutions is probably something you're going to have to do on the test. All right. Next question. In the equation 42 minus 3x equals 8, what is the value of x plus 6? All right, so this one is an equation. Okay, so it sounds like we're going to be solving. It says, what is the value of? That means solving, right? But instead of x here, it says x plus 6. So solving for x is going to be helpful, but it's not going to be ultimately my answer So I need to do a little extra work at the end. So first off, let's just solve for x. 42 minus 3x equals 8. All right, first thing I should do is, that's right, subtract 42 from both sides. 42 minus 42 is 0. And 0 minus 3x is minus 3x. 8 minus 42 is going to be 34. Negative 34. All right, next step would be to divide by negative 3 on both sides. Negative 3's cancel, leave us with x equals negative 34 over negative 3. Now, two negatives divide to be a positive, so really, I can just think of this as positive 34 thirds. All right. Now, if you notice from your answer sheet, this is showing that it's 11. All the answers are in mixed number form, so I would go ahead and divide that. I get 11.3 repeating, which of course is 11 and 1/3. Now that's what x is, okay? Now you see that distractor answer on there? That answer, 11 and 1/3, is one of the answer choices. They want you to feel good, like, oh, I solved for x and I see that 11 and 1/3, I got it. But it's not right, because we're looking for the value of x plus 6. So if x is equal to 11 and 1/3, go ahead and modify this equation, right? Add 6 to both sides. What is that going to make the left side? That's going to make it x plus 6, which will equal 17 and 1/3. X plus 6 is equal to 17 and 1/3. So 17 and 1/3 is the answer you should choose. All right, next question. For all x and y, 3xy squared minus 12x to the 4th y to the 3rd equals. All right, so first thing I want to look and see, is this an expression or an equation? All right, I see an equal sign, so it must be an equation, right? No, remember we said it has to have a left side and a right side to be an equation. So we are going to call this an expression. Now, what do we do with expressions? We either evaluate or we simplify. So we're going to simplify this. They don't tell us the value of the variables, so we know we're supposed to simplify. Now, one thing I notice about this is there's x and y's in both, and both those numbers 3 and 12 kind of have a common multiple here. So this looks like greatest common factor. So I'm going to pull out the greatest common factor here. Now, I'm going to show you two ways to do this. First, I'll show you just kind of the fast way, and then I'll show you really what's going on behind the scenes. So first thing is, you notice that with the coefficient 3 and negative 12, that there's a common thread there. There's a 3 as a multiple in both of those. So you pull that out front. Then I notice there's an x in both. There's more than an x on the right, on the 12, x to the 4th. But there's at least, or the best I can do is pull out one of those x's. So I'll go ahead and write that x. Now, how about the y's? What's the greatest number of y's I can pull out? I can't pull out 3 because there's not 3 y's there. So I have to pull out only 2, so y squared. Now remember, when you factor, you're sort of dividing out. When you pull out the greatest common factor, at least. So I'm dividing whatever I had here by this 3xy squared. Because remember, when I distribute back in, it's multiplying, so the opposite would be division. So when I divide, I take out that 3 and that x and those y squared. What's left here? There's nothing. But I have to put something. If I don't put anything, if I were to distribute back, you wouldn't get anything, and it wouldn't show that you were back to where you started. So I've got to put a 1 here. Okay, got to put a 1. It's really important that you see that. It's not a 0. Got to have a 1 there. All right, when I factored out that 3, that left me a minus 4. There was 4 x's originally, but I pulled one of them out, so that leaves 3 behind. And then I pulled out 2 y's, which leaves 1 y. So this is the equivalent expression for all x and y. 3xy squared minus 12x to the 4th y to the 3rd is equal to that. Okay, now how do you know if you did it right? How do you know if you factored it correctly? Let's think about this. Factor 35. What do you get? Put it into 2 factors. Yeah, you get 5 and 7. How do you know you factored that correctly? Multiply them together. What do you get? Is it back to where you started? Then you factored it correctly. So if we think we factored this correctly, the way I could test it is to multiply it back in. Boom, boom, I distribute. I get back to where I started. If I look at this, 3xy squared times 1. If I multiply 3 times -4, I get -12. X times x to the third is x to the fourth. Y squared times y is y to the third. I'm back to where I started. Okay, these are the same. So that means I factored it correctly. All right, so real quick, if you're not really good at factoring like this, break it down into these little factor trees, 3xy squared. So 3 is a prime number, x is here, and there's 2 y's. So this factors down to this, okay? If I factor this thing down into all those little parts that multiply to be it, that's what I get. Now the -12, first of all, this breaks down into -1 times 12. This breaks down into 3 times 4, and 4 is really 2 times 2. And then, so I put all these factors back together. I get -1 times 3 times 2 times 2, and then all the variables. There's 4 x's, 1, 2, 3, 4, and 3 y's, 1, 2, 3. So when we say greatest common factor, there's a 3 in both. That's the common part, right? But greatest means you got to get everything. So there's an x in both, and there's 2 y's in both. That's why our common factor is 3x y squared. Okay, if you need to break it down like this into these factor trees, you can do that. It helps especially on bigger, more difficult problems. This could be very, very beneficial. All right, next problem. Which of the following is equivalent to 5p minus n minus 2 times n minus p? All right, so this is definitely an expression. There's no equal sign, so it can't be an equation. We're going to be simplifying. We don't know the values of n and p, so we can't evaluate. All right, so this looks like there's 2 things inside of this parentheses. There's 2 different terms. When I see that, I almost always am distributing. So I'm going to go ahead and distribute, and multiply these 2 things inside. So first thing, 5 times p, 5p. Minus 5 times n, it's 5n. All right, you got to be careful here. This is a minus sign in front of that 2. Do not lose that minus sign. Every number has a sign. You've got to remember to look out for those negatives. All right, -2 times n is minus 2n. -2 times -p, the 2 negatives make a positive, and 2 times p is 2p. To p or not to p? Sorry. All right, 5p and 2p, those combine to make 7p total, right? I've got a -5n and a -2n. Those are -7n when combined. That is your equivalent expression to the original. All right, next one. For all n minus 5 times n plus 2 is equal to. Okay, so is this an equation? I see an equal sign. No, this is not an equation. It's got to have a right side. Question marks do not count. So what do we do here? Some people might say FOIL. You're absolutely correct. Some people might say distribute. You're absolutely correct. Some people might say multiply. These are all correct. So what we're going to do here is take the very first term, this n, and we are going to distribute. Now what do we do when we distribute? We multiply. Okay, so this n times n is n squared. Remember that 2 just means that we multiply 2 n's together. It's just kind of helping keep track of how many we have. N times 2 is 2n. Remember, you can't miss that one. Any number times any variable, you just put the number in front of the variable. All right, next thing we're going to do is distribute the 5. The -5. Don't forget that negative sign, right? You always are on the lookout for negative numbers. Don't just think it's a 5. It's easy to just not see the negative and just see the 5, and that'll get you into trouble. So -5 times n is -5n. -5 times 2 is -10. I have terms that are the same here. Okay, so I want to go ahead and combine those. It's like if you ask somebody, hey, how much money do you have in your wallet? They said, I have $1 and $1 and $1 and $1 and $1 and $1. Probably look at them like you're crazy. Just tell me how much you have total. Don't tell me these little pieces of what you have. Just put it all together. Tell me what you got. That's what we're doing when we combine like terms. So that 2 and that -5 makes -3 total. So we get n squared minus 3n minus 10. And that, for any n, is equivalent to what we get at the beginning. All right, next one. What is the value of the square root of 13x minus 3x squared plus 2x squared if x is equal to 4? Okay, so this right here is not an equation. There's no equal sign. Okay, now it says what is the value of? So that makes me think like maybe I'm going to be evaluating. That word value is in the word evaluate. Okay, so what is the value of this if x is 4? Well, let's check it out. Let's just plug in a 4. So we get the square root of 13 times x. Well, what is x? X is 4, so we're going to replace it with a 4. Minus 3 times x squared. Don't use the x, use the 4. Never use the x once you know the value of it. Plus 2 times 4, being careful here, squared. All right, this is all PEMDAS. Start with what's inside the groupings. So I have a 2 times 4 here. That makes an 8. Okay. Also, this little square root symbol is a grouping. So I want to do whatever's inside of here as well. So I can go ahead and do the squaring first. So I get the square root of 13 times 4 minus 3 times 16, right? Do those squares before you do any of the other multiplication stuff. Sorry, you'll have to excuse me getting texts at work. All right, so now I'm gonna go ahead and square this over here. That makes 64. And going back to what's inside here, back to PEMDAS, thinking I should multiply before I add or subtract. So I'm gonna go ahead and multiply the 13 times the 4. That makes 52. Minus 3 times 16 is 48. Okay. Also, let's see, then I subtract, because I'm still working within this grouping symbol, I get a 4. Okay, now I've still got my plus and my 64 all over here. Square root of 4 next, that's 2, and 2 plus 64 is 66. Okay. Oh, let's go back to that actually for a second. So you can do all of this on your calculator. If you type this into your calculator, you are good to go. A couple things to note though. Notice how I'm putting those numbers in parentheses. If that number was negative, it's an absolute must that you put it in parentheses, okay? If it's positive, you can get away with it sometimes, but I just put it in parentheses every time. Safe, nothing to worry about there. Okay, but you could definitely type this first part right here in your calculator and it's gonna spit out a 66. It's a preference thing. Would you rather use a calculator? Do you feel more comfortable typing it in, or do you feel more comfortable working it out? It's really up to you. Okay. All right. In the equation AB plus CD equals Y, what is CB? All right. So we have an equation, and it says what is CB? That sounds like solving to me. Okay. So I need to solve for CB. So AB plus CD equals Y. Now, there's a lot of room for error here. CB. Well, there's a couple things here. It's sort of tricky because there's an A attached to the B. So I can't really get rid of that A very easily without introducing. If I divided by A, I'd have to divide everything by A. And then I'd have a C divided by A, which gets me further away from my goal. So I don't actually think that's a good choice there. Instead, I think I'm just going to solve for C. Okay, if I can solve for C, then I can multiply that by B, and I'll have it, right? If I can get C by itself, right here, if I can get C by itself, then I just multiply it by B, and I'm going to have C times B. I mean, it's not pretty, but it's what it is. It's just one way to do this. All right, so let's go ahead and try solving for C. All right, so to get C by itself, I need to get rid of the D. That's my last step. But I also need to get rid of the AB, so I'm going to get rid of that. Now, AB is a term. I get rid of a term by just subtracting it away. Because it's a positive AB, I just subtract AB. It makes it go away. AB minus AB is 0, just like 10 minus 10 is 0. right? Two things that are the same, one of each. You take one positive, you subtract one away, you get 0. Doesn't work any differently for variables. All right, that gives me CD equals Y minus AB. Now remember, you can't subtract AB from Y because you don't know what Y or what A or what B is. So just write it out, okay? Don't be afraid. That's actually easy to do. If you're just not comfortable with it, it might scare you a little bit, but it's really easy actually. What's X plus Y? It's X plus Y. You just write it out. So last step is to divide by D, right? That's going to get rid of that D here. And I'm going to divide the whole thing by D. So I get C by itself. So I'm almost there. Now, where does the B come in? I'm just going to add it. I can do anything I want as long as I do it to both sides. So I'm going to multiply that by B, and I'm going to multiply this by B. So this thing times B, well, remember this is B over 1. 1 times D leaves the bottom as D, and then I distribute the B to both parts. So YB minus AB squared. I guess technically you won't see BY, you'll see YB. Oh my gosh. All right, sorry, technical error there. Let's just get back to C here. Make it a little easier. We had C equals Y minus AB over D. Okay, back to this. So remember, I'm going to multiply this by B, and I'm going to multiply this by B, and the B gets distributed to both parts. So I get BC equals BY minus AB squared. Remember that squared just means I've collected two B's with multiplication all over D. So that's it. That's what CB is. Sorry, I've got it as BC. It's the same thing. What is CB? Well, it's that. All right, next problem. Each of the following are solutions to the equation x minus 1 times x minus 3 times x squared minus 4, except, now, this should say equals 0 because it's not an equation, okay? So first of all, each of the following are solutions to the equation x minus 1 times x minus 3 times x squared minus 4 equals 0. All right, so let's see here. Let's list out what we got here. 1, 2, -2, 4, and what was the other one? Oh, there's a 3 in here as well. Sorry. All right, so here's our choices. So if I plug in 1, if it's a solution, when I plug it in, it should make it work. So if I do 1 minus 1 times 1 minus 3 times 1 squared minus 4, I should get 0 if it's a solution. Now what's 1 minus 1? That's 0. 0 times -2. If I simplify that, 1 squared is 1, and 1 minus 4 is -3. But really, if you think about this, 0 times anything is still 0. So as long as it's in factored form, if one of the factors is 0, the whole thing is going to be 0. So the fact that the 1 made this thing here 0 makes the whole thing 0, and therefore it's a solution. So this is a solution. 2, look up here, x squared minus 2. Sure, when I plug it in here, there's no 0. When I plug it in here, it's not 0. When I plug it in here, I get 2 squared minus 4. 2 squared minus 4, 2 squared is 4, and 4 minus 4 is 0. This whole thing is going to be 0 because of this factor right here. I get 1 times -1 times 0. That makes 0. Okay? So that means 2 is a solution. -2, if you plug it in, will do the same thing. If you square -2, you get a 4. So this third factor, this x squared minus 4, is going to end up being 0. And since we're multiplying the x minus 1 times the x minus 3 times x squared minus 4, you're going to get 0. Now 4 is not going to work. Let's look at 4. When I plug it in for x, I get 4 minus 1 times 4 minus 3 times 4 squared minus 4 equals 0. Now 4 minus 1 is not 0. That's 3. 4 minus 3 is not 0. It's 1. 4 squared is 16. And 16 minus 4 is 12. There's no way to get a 0 here, right? 3 times 1 times, that's 36. So because 4 does not give us a solution, we're going to say that 4 is our answer because it is not a solution to the equation. All right, for all x not equal to 1. Now look at this for all x not equal to 1. This is really not important. This is to kind of make you, it's kind of throw you off a little bit. All it's saying that because the bottom is x minus 1, x is not allowed to be 1. Because what would 1 minus 1 be if I plugged in a 1 for x? You'd be dividing by 0. Can't do that. So this is just a disclaimer, right? It's like saying, hey, can't sue us if you use x equals 1. You're not allowed to use x equals 1. So don't worry too much about this. This is not really that important. Basically what we're doing is we're saying, okay, this thing is equivalent to what? Equivalent, keyword, bing, simplifying, right? Equivalent to means simplifying. So what we're gonna do is we're gonna simplify this. Now, what you got to remember is when you get something factored like this, okay, now this this is not really necessarily a problem you'll see on the ACT. You'll see it in unfactored form, and then you're supposed to factor, but we'll get to that in a later lesson. So for now, I just want to show you about the canceling. You have 3 things on top, and there's 1 thing on bottom. Well, that 1 thing on bottom matches with the thing on top. So I'm actually allowed to cancel here, okay? As long as 1's on top, 1's on bottom, you're allowed to cancel. This also works if I had something like this. Even though they're not on the same fraction, I can still cancel 1 on top with 1 on bottom, okay? And that happens because it's all multiplication and division. See how this is something times something times something divided by something? And this is something divided by something times something divided by something. I'm not using plus or minuses here. If I had this, I would not be able to cancel because right here I have an x plus something. This is addition. Sort of like how 3 plus 2 divided by 2 does not equal 3. Okay? You can't cancel if there's a plus sign in there. Now you're going to argue with me and say, well, look, there's a plus sign right here. That's a plus sign, but it's locked into this parentheses. So really, this is all multiplication and division. That's why I'm allowed to cancel 1 thing with 1 thing. So if you see a plus sign, you're not allowed to do it, but if it's all multiplication and division, you can cancel at will. All right? Next problem. Each of the following are solutions to 3x plus 1 is greater than 13 except, okay? So let's try some of these solutions here. All right? 0. Is it a solution? Let's plug it in. 3 times 0 plus 1 is greater than 13. 3 times 0 is 0. 0 plus 1 is 1. Is 1 greater than 13? No. So that is not a solution. Remember, solutions are numbers that when we plug in, they say something true. What about 2? Okay, when we plug in 2, we get 3 times 2, that's 6. Plus 1 is 7. Is 7 greater than 13? No. So that means that's not a solution. Okay, what about 4? 3 times 4 plus 1, that's 12. Plus 1 is 13. Is 13 greater than 13? No. It has to be bigger than 13. It's not allowed to equal 13. So 13 is not bigger, so that is not a solution. All right, so we get D, 5. When we plug in 5, it's going to work, right? 3 times 5 is 15. Plus 1 is 16. 16 is greater, so it works. All right, E says none, but it's not that because we already found our solution. All right, next problem. Simplify the following expression. All right, so we're going to simplify this. Notice how there's a fraction. Whenever you see a big fraction like this, you might think of some sort of canceling. So we're going to find that greatest common factor. Notice there's an x and a y in both of these terms in the top. So that's the greatest common factor we can pull out. Now there's a 1 left over, there's a -5, and there's 1 y left over, right? There was 2. When I pulled one of them out, that left 1 behind. All right, that's over xy. Now, can I cancel here? Yes, because this is xy times this thing divided by xy. So since I didn't say plus there, even though there's a minus locked into those parentheses, this is all multiplication and division. So I'm allowed to cancel. Okay, we get 1 minus 5y. All right, next problem. This is going to be another one where it's an expression. Okay, so what do we do here? Well, we combine all our like terms, but first we've got to distribute. I see a group, a b and a -3 inside of parentheses with a number out front. We've got to distribute. Okay, so let's rewrite this. 2ab minus 3a plus 4ab. Now, -2 times a times b. That's just -2ab. Okay, just get those variables all together. Now, -2 times -3 is -6. And since the -2 is multiplied by a, we're going to get -6a. All right, I've got ab's and ab's and ab's. Put them all together. 2 plus 4 is 6. -2 is 4. So I've got 4 total ABs. And I've got an A and an A. Those can be combined. -3 minus 6 is -9. Here we go. All right, last problem. Write 8x to the third minus -2x to the third in simplest terms. All right, so this is definitely an expression. We're just going to simplify. Let's really focus here on order of operations. Okay, this one looks like there's a lot going on. So let's go ahead and multiply this thing out 3 times. Let's do our exponent first. Okay, so I just write it out 3 times. It's not that much work. When I do that, I still have my minus sign here, but these 3 things multiply the signs first. So negative times negative times negative, that's a negative. 2 times 2 times 2, that's 8. X times x times x, that's x to the third power. Okay, now I see double signs here. I see a minus and a minus that are right basically next to each other. So I want to go ahead and combine those as a plus, right? This negative and this negative combine to make a plus. So when you subtract a negative, you're really adding. So 8x to the third plus 8x to the third. Those are like terms. If I have 8 of something and I add 8 more, I get how many? 16 total. 16x to the third. All right, so that's it.